Welcome to the Deep Dive. We're your shortcut to getting genuinely well-informed fast. Ever feel like you're drowning in articles or just wish you could, instantly get the main points from new research? Well, you're definitely in the right place. We cut through all that noise. We give you the crucial understanding, maybe some surprising facts, and hopefully keep it interesting along the way. Today, we are plunging into the, pretty dynamic world of skincare innovation, and we're focusing on a real leader in this space, Amorepacific. Now, these guys aren't just another beauty company. They're a global powerhouse, really known for pushing boundaries with advanced cutting-edge stuff. They made a big mark worldwide, focusing on breakthrough tech.
That's right. And our mission today for this deep dive is really to explore how companies like Amorepacific are driving that innovation in the beauty space specifically. And we're going to do that by taking a close look at their patent activity. We've actually got our hands on a specific U.S. patent application from them, which, gives us this unique little window into what future skincare might look like. It's kind of a sneak peek into the lab. And just to give you a sense of how, forward-looking this patent. It was published on July 10th, 2025. So yeah, it really represents the sort of leading edge of what's potentially coming.
It's pretty amazing, isn't it? How much actually goes into shaping the future of something like, skincare, which maybe we take for granted sometimes. Amorepacific, like a lot of industry leaders, they pour huge resources into R&D, research and development. And their patent portfolio, it's not just a stack of papers. It's really a clear roadmap of their innovation. It shows the specific technologies they're inventing, refining, and, importantly, protecting for the future of beauty. Really shows their commitment to being right at the forefront. So the specific document we're digging into today is U.S. Patent Application Publication Number US 12250241863A1. And the title, that's kind of intriguing, Self-Retractable Patch for Skin Stimulation. Hey, Ray, right away that tells you this isn't just like a new face cream or your standard sheet mask. This is a glimpse into a very precise patented technology designed to, maybe fundamentally change how we deliver physical stimulation to our skin. It definitely hints at some kind of automation we haven't really seen much in this space before.
Yeah, and what's important to grasp about a patent application is that it's more than just legal stuff. It's really a strategic declaration. It shows a company's future vision. It clearly tells us where they're putting their innovation resources, what they think will be valuable enough to protect legally down the line. And on this specific patent, the inventors listed are Kumsoo Han, Jongyu L.E., and Jongmin L.E., all from Amorepacific Corporation in Seoul, Korea. So it kind of grounds it, gives us a sense of the dedicated team working on these advanced solutions, trying to solve very specific problems.
Okay, so let's unpack this then. Whenever a company develops something totally new like this, it's usually, a direct response to some existing problem or limitation they see. So what exactly is this self-retractable patch trying to solve? What are the frustrations?
Well, the patent itself points out the downsides of, let's say, traditional skin stimulation methods. Things like maybe those bulky massage machines or even derma rollers. Think about it, they're often kind of inconvenient for daily life, right? Sometimes they need plugging in or batteries you have to keep changing. Right, the power source issue.
Exactly. And they can be pretty complex to manufacture too, which often means they cost more for us, the consumer. And there's also maybe the hassle of keeping reusable devices clean and hygienic.
And that's precisely where I think the core genius of this patent really comes in. Their goal is basically to eliminate all those common issues by creating a patch that stimulates the skin autonomously, completely, without needing any external power. What's really fascinating here is how they're proposing to achieve this self-sufficiency. Effectively making the patch a truly smart device that just activates itself. And this isn't just about convenience, though that's huge. It's also about maybe democratizing advanced skincare. Imagine taking what feels like, clinic-level stimulation out of those specialized settings. Making sophisticated treatments more accessible, maybe more affordable for everyday use, without all the bulky gear or complex steps. That's a pretty big leap. Potentially.
That's the real key then, isn't it? The patch activating itself. The patent abstract. It breaks down this core idea. It's a self-retractable patch. And it combines two main bits. You've got what they call a retractable material, and then there's a trigger material. The crucial part, it seems, is that the trigger material applies some kind of preset energy to the retractable material. And that energy makes it contract. It sounds like a very elegant, almost passive way to get it going.
Indeed. That spontaneous retraction, that's the critical innovation here. It simplifies the whole user experience massively because you're not fiddling with buttons or settings, you're not charging anything, you don't need to apply force yourself. And it also streamlines manufacturing, right? By removing the need for embedded electronics or power sources within the patch itself, it's basically designed to react intelligently to its immediate environment, specifically your skin.
Okay, so how does this self-retraction actually work? Let's get into the nitty-gritty, the materials.
Yeah.
Because this is where the science gets, well, pretty cool, I think. First up, there's the retractable material. The patent calls it C. This is the part that physically shrinks or pulls, right?
Right.
The patent mentions it could be a hydrogel, those polymers that soak up water, or more specifically, poly N isopropyl which is often just called PNAM. Now, PNAM is apparently quite special because it's a thermoresponsive polymer. What that basically means is its physical structure, and therefore its volume, changes based on temperature, inherently. Which makes it incredibly efficient for this kind of job where you want a physical change without needing, like, a tiny motor or some complex mechanism. Think of it like a built-in microscopic muscle, maybe.
Yeah, that's a good way to put it. And if the retractable material is the muscle, then the trigger material, what the patent calls T, is definitely the brains, or maybe the spark plug. This is the bit that provides the precise energy needed to make the retractable material, the PNIPM, actually do its thing. And the patent explains it can generate this energy through various, quite ingenious means.
And they give some really clever examples in there. It mentions water-sensitive self-heating materials like zeolite. You might know zeolite from, like, dehumidifier packs or some hand warmers. They release heat when they get damp.
Right, that exothermic reaction.
Or it could be specialized metal oxides, alloys, even tiny engineered nanoparticles, each designed to release energy in response to some specific trigger, maybe offering even more precise control. But here's where it gets particularly interesting, I thought. The patent specifically mentions a mixture: glycerin, zeolite, and Keltrol F. Now, Keltrol F apparently is a type of natural gum, often used in cosmetics and food as a thickener or stabilizer.
Right, and their research, as detailed in the patent, shows that this specific mix, when it gets activated, presumably by skin moisture, can raise the temperature to about 40 degrees Celsius.
40 degrees C. Okay.
Yeah, within about 15 to 30 minutes, and then it can hold that heat for a decent amount of time.
That's quite specific.
It is, and they also mention another really thought-provoking trigger material, capsaicin.
Capsaicin, like from chili peppers. Seriously.
Yes, exactly like that. And it's not just a random, quirky ingredient choice. It's a great example of how Amorepacific seems to be pioneering these bioresponsive materials. They're leveraging our body's own natural reactions, like that feeling of warmth you get from capsaicin, to trigger very specific localized effects in the patch. It sort of moves beyond just passive application, doesn't it? Towards a truly active, intelligent interaction with our skin.
From a user point of view, how significant do you think that autonomy, the patch just doing its thing, really is in a daily routine? Oh, it's huge.
Yeah.
I mean, no more trying to plug in some clunky derma roller while you're, I don't know, trying to make coffee, right? This patch sounds like it gets the modern multitasker. And it's not just the materials. The structure of the patch is also really clever. It's not just flat. If you picture it, it apparently has these tiny strategically designed holes all over it, like a microscopic sieve almost.
Okay.
And these aren't just for looks, they're functional. The patent says these holes, H they call them, are designed to be between 1 and 5 times the average size of a human skin pore, which sounds carefully calculated, to maximize the stimulation effect. And what's really cool, there are figures in the patent, like figure 4, that apparently show these holes actually shrinking.
Ah, so you can visualize the retraction.
Yeah, contracting over just a few minutes, maybe 60 seconds, 90, up to 240 seconds. And as they shrink, they pull on the skin. It illustrates that dynamic response really well.
Okay, so let's put all those pieces together then. Try and understand the full mechanism. You apply the patch. Simple enough. Then moisture, maybe just from your skin, maybe ambient humidity activates the trigger material, let's say the zeolite mix. Right. That zeolite starts to generate heat. This heat then causes the retractable material, the PNIPM, to shrink.
Okay.
And as it shrinks, the patch exerts this gentle physical pull on your skin, specifically through those holes we mentioned, providing targeted physical stimulation, all without you doing anything manually or needing an external device. Which does raise an interesting question. What kind of precise, controlled stimulation could this offer compared to, say, manual massage or a roller? And what are the potential benefits of that specific kind of targeted pull? Maybe better circulation, enhanced absorption of other ingredients. The patent might hint at that.
That's a great question, and it really points to the potential here, doesn't it? And just to show how versatile they envision this being, the document describes various embodiments, different versions, basically. It's clear they've thought about a whole range of applications and functionalities. You could have simple, single-layer designs. Straightforward, easy to make, probably.
The basic model.
Right. But then it gets more complex. There are two-layer designs described. These could even include a separate warming patch layer alongside the main retractable one.
Ah, so you could get a warming sensation first.
Exactly. Maybe to relax the skin or improve absorption before the main stimulation kicks in. And they even detail three-layer designs incorporating additional layers, which suggests, potential for even more complex functions down the road. Things like targeted ingredient delivery, maybe? Or specialized therapeutic effects. It's clear they've really explored the breadth of what this core tech could potentially do. So wrapping up this deep dive, what we've really seen is, I think, a fantastic example of Amorepacific using advanced material science, smart materials, to create these self-sufficient skincare devices. This self-retractable patch with its really ingenious combo of a thermal-responsive material and a self-activating trigger. It's just a prime example of innovation aiming for ultimate convenience and efficacy, too. It totally removes the need for external power or bulky machines. It basically puts advanced skincare on autopilot. And also makes you wonder, doesn't it, about the wider implications for the cosmetics industry. How might this influence product design, user experience, even supply chains, maybe, if these self-activating materials become more common?
Indeed. And that leads to the bigger question, perhaps for you listening. What does all this really mean for the future of personalized beauty and wellness? Could we genuinely see a future where our skincare routine involves these kinds of smart patches? Patches that not only adapt and activate themselves for stimulation, but maybe also for highly targeted ingredient delivery, or even, potentially, for diagnostic purposes. Imagine a patch that, analyzes your skin's immediate needs, hydration, maybe oiliness, and then autonomously releases specific compounds, or provides real-time feedback on your skin's condition, perhaps tracking hydration levels or exposure to environmental stressors like UV or pollution. This kind of autonomous technology really opens up a whole new realm of possibilities for how we interact with our beauty and health products, making them more integrated, more intuitive, maybe truly responsive to our individual needs. It's certainly something to think about, just how much more intelligent will our everyday products become, and how will that change our relationship with them?